Welcome all. Thank you for being here in the 11th lecture of the East Aegean and Anatolian Archaeology lecture series. The presenter today is Professor John Haldon. Many of us, I'm sure, know him, especially the Byzantine history workers, students, and academics. He's going to be speaking about aspects of Anatolian history in the Byzantine period, town and countryside, circa 600 to 900 CE. Professor Haldon is a fellow of the British Academy, and he is the current director of the Princeton Climate Change and History Research Initiative, as well as the director of the program in Medieval Studies Environmental History Lab. He is Emeritus Shelby Colum Davis 30 Professor of European History and Emeritus Professor of Byzantine History and Hellenic Studies at Princeton University, and a corresponding fellow of the Austrian Academy of Sciences, a member of the Archaeological Institute of America, and a member of the British Institute in Ankara. He has served as the president of the International Association of Byzantine Studies as well. His research focuses on the history of the medieval Eastern Roman Empire, that's the Byzantine Empire, in particular in the period from the 7th to the 12th centuries, on state systems and structures across the European and Islamic worlds from late ancient to early modern times, on the impact of environmental stress on societal resilience in pre-modern social systems, and on the production, distribution, and consumption of resources in the late ancient and medieval world. And today's discussion is going to be very illuminating, both in terms of the archaeological evidence that we are going to be viewing regarding the Byzantine period, but also methodologically, and specifically methodologically, because it's going to be combining archaeological evidence together with the environmental evidence and historical textual evidence. So, Professor Haldon, thank you for being here with us today, and the floor is yours.
Thank you very much, Chidem. It's a very kind introduction. Obviously, I can't talk about all of those interests today. I'll limit myself to one small element, but it's a great honor to be invited to talk to the group, and I've looked at some of the papers that have gone before and seen what a really interesting lineup you've got, covering so many varied aspects of Anatolian history. What I want to do today is to look at a particular aspect of the history of urban settlements and their relationship to their rural hinterland in Anatolia. And I'm going to focus in on two sort of zones or catchment areas that we've looked at, although I'll refer to a number of other zones as I'm going through my comments. And one of the points that Chidem just mentioned is of relevance here, because one of the difficulties that historians and archaeologists still face is how to integrate their historical and documentary evidence with the paleoscientific data, given that those three disciplines, the paleosciences, archaeology and history, approach the same question from very different angles, and they use a different vocabulary, and perhaps more problematically, they often use the same term or the same word to mean rather different things. But we can come back to that later on. I think I can assume that everyone's familiar with the basic geography of Anatolia, and the basic geography of Byzantine Anatolia is, like periods before it, and to some extent even today, determines rather the pattern of communications and settlement and agricultural exploitation. On the point about the relationship between paleo-environmental science and let me just move my sorry, I can't seem to, there we go. On the point about the relationship between climate science and history and archaeology. Some of you will be familiar with an article by Yanis Telelis, published in 2008, where he went through a lot of the data for the Byzantine period, which we can extract from written texts about climate and environment. And he pointed to the enormous problems inhering in that material. The biases, the authorial biases, the problems of geographical location. For example, nearly all the Byzantine evidence or written evidence about climate and climate impacts is written from a Constantinopolitan standpoint, not all of it, but most of it. And that, of course, makes it quite difficult to use. Nevertheless, one can combine all the different textual evidence to produce the sort of graph that we see on the left of the screen to give us some indication of how climate impacts were perceived, at least, and registered in the literary sources. As I said, what I'm going to do now is to summarize some of the results of recent work. I've brought it up to date in terms of the paleoscience data, the pollen evidence in particular, up to 2020. Some of you will be familiar with some of this material, others not. And I'm going to focus on some particular sort of catchment areas that we've looked at to try and elicit information about the relationship between urban settlement, rural settlement, and landscape in the period from about 500 to 900, a little bit beyond. So beginning with the archaeological evidence, as we know, systematic regional survey archaeology offers the possibility of surveying a region and landscape holistically, noting trends in settlement and construction, and to hypothesize the ways in which communities related to one another and led their daily lives. But surface and area survey rarely permits precise chronologies, nor can it usually indicate more than general patterns in settlement and certainly in landholding and production. Where survey and related regional research together with excavation of sites can be combined, then again, as we know, artifacts can be placed into a datable, functional and stratigraphic and hence chronological context. But combining results from many different projects is a difficult process because of different methodologies, dating systems and so forth. And in fact, when one tries to combine information from say 5 or 6 different field surveys, it actually proves quite problematic because everybody appears to be using different criteria upon which to collect and systematize their data. So that's the first problem that we face just within the archaeological discipline. Despite such difficulties, of course, the benefits of survey work do help us to establish a broad picture of regional development over time. And this is essential to putting both rural and urban settlement into their context. Another key archive for reconstructing rural life derives from pollen analysis, which I'll talk about in a bit. And this tells us about land use and vegetation. And by using multiple pollen records, it's possible to reconstruct regional vegetation histories as long as there's reasonable dating control, primarily through carbon-14, and an appropriate range of samples. Of course, again, this data isn't free of methodological complications. Limitations linked to the ways in which pollen grains are produced, dispersed, and preserved can hinder data interpretation, sometimes producing a record that is biased and or incomplete. Some categories or taxa of different flora, for example, pine, produce many more pollen grains and their pollen is dispersed much more widely than that of others, such as cereal pollen. Other plant types have pollen that is relatively resistant to oxidation and hence can be overrepresented in the record. A number of economically useful plants, such as cultivated fig trees, are completely absent in the pollen record because they're pollinated by insects rather than by the wind. And all this sort of thing means that past pollen percentages cannot be directly equated to plant abundances, in other words, outputs. Most pollen sequences, nevertheless, represent continuous vegetation histories that can span periods for which historical, that's to say documentary records, are sparse or lacking or interrupted. And so for our purposes, this means that pollen data have a special value in understanding the economic and environmental transition from antiquity to the medieval world, where both the textual and the archaeological records are far from complete. Our project has focused on 4 sub-regions within Anatolia, which you can see in the map on the screen, where you can also see the archaeological sites and the survey material that we've used. I'll only have time to discuss 2 of these, regions 3 and 4, in any detail, but I'll come back. I'll refer to regions 1 and 2 and 1 or 2 other sites as I go through my material. And these 2 regions, 3 and 4, will serve to illustrate some of the main points I want to make. These regions represent primarily 4 geographically and ecologically distinct zones, including altitude, which determines many of the crop choices available to farmers, the coastal zone with ports and generally good access to distant markets, and our sites are Cide and Sinop, the central and northern plateau, Avkat, Çadırhöyük, on the map there. You can see them, C and D. The interior uplands in the southwest, with varying degrees of forests and meadows around Sagalassos, Balbura, and I look more particularly at the Göksu, the upper valley of the Göksu, and the south central plains on the Anatolian plateau, such as the Konya plain. These zone definitions are focused both on different ecological zones, including altitude, as I've mentioned, and this determines in many respects the choices available to farmers in terms of crops. Note that for the most part, none of these regions, a couple of exceptions, none of these regions include very many of the major excavated urban sites or major urban centers of the late Roman and Byzantine worlds, so that we've concentrated on our attention on less well-known and, if you like, less important settlements. And one of the reasons which, again, some of you will be familiar with from our publications, one of the reasons we selected Avkat, modern Beyazı, near to Çorum as an important focus for work was because it really wasn't an important place in medieval times. It had some significance, but it wasn't a major city like Ephesus or Amorium or so forth. And we need to know a lot more about this sort of middling rural urban settlement. So, as I said, pollen percentages can't be related directly to levels of agricultural production, but it is possible to calculate regional averages for key pollen types. And we've done this in each of these subregions, and thus combined with the data from archaeological surveys, we've established some demographic trends, because pollen percentages do reflect relative levels of production, not absolute levels, but relative levels of production, and thus population, depending on the crop, of course. We can then compare these results with well-dated climate records from Northwest Anatolia and from Greater Cappadocia, for example. But given the incompleteness of some of the data and the fact that the different types of data don't always overlap, our analysis is necessarily incomplete. But still, where the data do overlap in space and time, pollen and archaeology can allow rigorous comparison and provide genuine insights into long-term social economic dynamics. And then when we combine that with the available historical data, we begin to build up a more granular picture of what was going on. The general trends in patterns of settlement for most of Anatolia across the period from the later 6th into the 10th century are relatively well established, and the survey data we have synthesized does not substantially challenge the existing picture, except in some details that concern specific sites. Rural settlements north of the Pontic Mountains from the 4th to the 7th centuries were dominated by 2 major factors: the distinctive subtropical climate and the easy access of coastal ports to Constantinople and other Black Sea markets. We collected site count data and aggregated the information by category and period in order to generate a very rough typological guide to processes of increasing and decreasing settlement. So in the Sinop region, and compared with Roman imperial times, it became clear that the number of sites in the period from the 4th to the later 6th and early 7th century actually increases by some 500%, 5 times. And together with the nature of site assemblages in rural areas, points to the emergence of industrial scale production of olive oil, for export, of course. The distinctive microclimate of Sinop, together with the easy access to maritime trade routes, may have produced the spectacular rise in rural sites and production during this period. A more modest threefold rise in rural settlements in the Cide survey during the late Roman and early Byzantine period that we'll see in a moment probably also reflects demand from major urban centers, and in particular Constantinople. In the interior of northern Anatolia, rural settlement seems to be largely based around a network of good roads and small-scale dispersed rural settlements, including farmsteads connected to larger urban centers. The center at Çadırhöyük, for example, sits among a network of pier sites, which included the larger late Roman center at Kirkenes, as well as settlements in the vicinity of Uşaklıhöyük and Alışa. These were all connected by the Tavium-Sevastia road, the same road that today runs between Yozgat and Sivas. The survey data indicate a period characterized by substantial trade networks and non-isolated settlements, even in seemingly isolated modern environments. But for the following period, though, from the 7th to 9th centuries in contrast, there is some considerable shift in this pattern. It's still difficult to assess completely because of the problems we've got of identifying and dating local ceramics. But at Sinop, there's a very clear reduction in settlement numbers and a visible retrenchment of the oil-producing economy after around about 600. The city of Sinope itself had expanded to encompass some 70 hectares by the later 6th century, with comparable expansion in some of the nearby suburban districts, and with evidence for fluctuations in focus and density of occupation between inner and outer suburban regions that presumably reflected shifts in market and local social relationships. But in the course of the 7th to early 8th centuries, it contracts to some 35 hectares and was enclosed by the city wall, while evidence for the nearer as well as more distant rural zones indicates a very dramatic reduction in settlement sites, a reduction of some 80%. We've graphed and averaged the data from the survey here, and where the orange bar is, that's the period of dramatic decline, if you like, or collapse of settlement numbers. And given the relative totality of the survey in terms of field walking and aerial work, we're fairly sure that that picture is reasonably accurate. Of course, the exact chronology remains problematic for the reasons I mentioned to do with the ceramics and the on-site excavation and location of ceramic data from individual rural centers. In contrast with Sinop, Egialos, or modern Gide, some distance to the west, was a much smaller urban settlement located in a wide coastal plain, making it a logical place for a coastal settlement, and its archaeology suggests substantial seaborne contact with the wider Roman world. But from the middle of the 7th century again, the ceramics show a shift from the red slip wares of the late Roman period to assemblages made up almost entirely of coarse, locally produced utilitarian wares. This is obviously in common with many parts of Anatolia at this time. But the city itself is not mentioned in any text of the Byzantine period, suggesting that it lost any pretensions to urban status in this early 7th century time. The ceramics demonstrate settlement continuity, but on a very much reduced scale. On the other hand, while settlements contracted or disappeared from some rural districts nearby, others show some continuity and continuing development, including the maintenance of substantial churches and defensive installations. The late Roman, early Byzantine period in northern and central Anatolia seems to be largely characterized by a continuation of the Roman model of villas and agricultural settlements, with indications of modest wealth as defined by the presence of imported goods and public architecture, such as churches. The overall pattern is of small-scale villas or farms found connected to larger sub-regional centers. And this is the context for the rural settlement at Çadırhöyük, located on the plateau among a network of sites that were connected by the Tavium-Sevastia road, which I already mentioned, and related to the larger Roman settlements, which I already mentioned at Kirkenes and others nearby. And there you can see where Çadırhöyük is located. And there's the landscape overlooking the site. From sometime in the 7th century, however, again, chronology is only really, we have a 50-year bracket within which to try and date things. The settlement entered a period of economic retrenchment, fairly dramatic economic retrenchment, stretching into the late 9th century, marked by an absence of coins. Again, that's actually, of course, not unusual in Anatolia, as we know, certainly from the 660s on, but also an absence of any luxury goods and fine wares. And this period saw a clear shift from the late Roman pattern, visible in minor rebuilding that is contiguous with floor levels, exhibiting a lack of clearly datable goods, but with locally made red wares clearly post-dating the 6th and early 7th century material. While the relatively poorly produced ceramics, in comparison with earlier wares, that is, their presence indicates continuity of settlement and population, but on a much reduced scale, with a reduction across the wider region of the number of identifiable settlements, although further extensive survey is still required. But by the later 9th and 10th century, the broader pattern has shifted again to emphasize localized protection rather than on imperial networks connecting urban, suburban with rural sites. The central sites, rather than being urban, are often larger defended rural sites, which offered protection or organization, and Chadha exemplifies this with a substantial fortification on a central mound, with both internal buildings as well as defensive towers on at least 3 sides, and yet it was never an urban center, and it was never occupied in terms of space use on an urban basis. But it does seem to have been a well-planned substantial fortification. It was very small, maybe 2 to 2.5 hectares maximum, and it presumably functioned to provide protection to the settlements on the terrace below and possibly other farms and small settlements in the vicinity. Efkaita, modern Avkat or Beyazı as it's now known, we're looking from the what we call the Kale Tepe here down southeast towards Mecdazu. Efkaita lies in the southern foothills of the Pontic Mountains and on the northern edge of the central plateau. As a local center, it was a relatively recent development of the later Roman period, its appearance accompanying the growth of the cult of Saint Theodore the Recruit, from the later 4th century. And like Chadha, it was part of a trans-regional system connected by routes that formed part of a wider network. Data from the Avkat survey for the 7th and 9th centuries indicate a reduction in the number of sites across the wider zone, although landscape use appears to continue as in the previous period. But in the immediate vicinity of Efkaita, in contrast, there seems to be an increase in the number of habitational or agricultural locations, beginning in the mid-7th century and extending to the end of the 8th century, although, as with virtually all other Anatolian sites for this period, coins are more or less absent after the 650s. And our chronology, of course, is also somewhat imprecise. We never had a permit to excavate at Efkaita, unfortunately, although that work could still be carried out. And so we don't have precise chronology once we get to the end of our late Roman coursewayers. But this suburban, if you like, continuity and possibly even expansion of extramural settlement indicated by the survey does present something of an anomaly. And it may be associated with an expanded use of the fortified Kale overlooking the town, an enhancement that corresponds to the increased militarization of Anatolia, within which Efkaita played a role. And there's the averaging of the Avkat site numbers. And there you can see that the average of rural settlement is considerably greater than that in the previous graphed illustrations of site survey data. In contrast with the western coastal zone of Anatolia, with its major cities such as Ephesus, Pergamum, and Nicaea, the only large cities in the southern region were Tarsus and its smaller neighbor Seleucia. There were few cultivable plains in the southeast, on the south coast, I beg your pardon, and in the interior, such as the Konya Plain, large-scale irrigation systems are required to supplement rain-fed cultivation of cereal crops. If we go back to the map of zones, so we're in zone 4, or beginning to approach zone 4. In inland Isauria, the settlement pattern included small cities, mostly created from villages during the 1st century CE, and often very close together. Claudiopolis, for example, modern Mut, the largest city in the region, was located only 5 kilometers west of the urban settlement we don't know its ancient name, but an urban settlement, Sinobuc, whereas the closest city in the other direction was Adrasus, more than 30 kilometers away. Urban territories thus varied very considerably in size. The evidence for the Upper Göksu Valley indicates continued occupation of almost all such minor sites, although at much lower levels of intensity after the 7th century. Today, there are 3 zones of rural settlement in this region, defined by altitude and agriculture. A lower lying zone of cereals and fruit trees, such as apricots and figs, up to about 300 meters above sea level, is followed by an intensely exploited zone from 300 to 800 meters, in which mostly vine and olive cultivation and the majority of the villages takes place. Beyond the 800-meter line is a further zone of villages, with some seasonal rural settlement on the yailas and refuges with cereals and some fruit trees, especially apples. Archaeologically, it looks as though not all of these sites were occupied in all periods, but there's no clear pattern to settlement continuity. And again, without excavation of many of the sites, we can't really tell what the length of occupancy was and the relationship of that length to neighboring settlements and broader historical developments. So there's no clear pattern to settlement continuity here, and just as lack of settlement continuity in modern times is often correlated with shortage of water, this may likewise have left settlements vulnerable to any changes in climate during late antiquity and early medieval times. So hydrological issues may also play a role, and that needs further investigation. Cities, very loosely defined, were distinguished from villages in several ways, in particular in size, but also in defensibility. Several of the regional towns or cities lay above 1,200 meters above sea level, modern Ermenek, and then Darpazara and Adrasus. And it was common to construct a city around an acropolis on high ground, such as at Mut or Sinobuc. The late Roman period saw the most intense occupation of the countryside at any period until the late 20th century. But from the middle of the 7th century, there was a dramatic loss of settlement continuity. The historical context for the 7th century onwards involved continuing insecurity and instability along the Taurus frontier, a situation that one might also expect to see reflected in changes in settlement patterns. But by the end of the Middle Byzantine period in the later 11th century, settlement numbers had in fact returned to a level similar to that of the early Hellenistic period. And again, that graph, again, without the exact chronology that we would need to be very precise, and averaging the histories, as it were, of a number of settlements together, gives you that picture. Some of the changes visible in the archaeology of rural settlement in the Upper Göksu Valley are a result of a reduction in the volume of identifiable imported pottery. Fewer fine wares has meant that the number of datable sites recorded for the period after the early 7th century diminishes. This reduction can be explained variously through demographic change as a result of plague or war or migration, as well as shifts in patterns of exchange as shown by ceramic supplies, but perhaps also, but only after the middle of the 8th century when a phase of increased aridity set in, perhaps also climate change leading to reduced agricultural productivity. Again, a good deal more work needs to be done before we can move beyond these rather crude generalizations. We can, however, complement the results from the Upper Göksu region with data from others in southern Anatolia. The Upper Göksu Valley covers a broad range from near to sea level to over 1,200 meters. Other regional archaeological surveys cover a narrower range at or above 1,000 meters above sea level. Those from southwest Anatolia represent the Taurus mountain zone, comprising well-watered uplands, mainly limestone terrain, and intervening intermontane valleys with surveys centered around important classical sites, such as at Sagalassos, where there's also been extensive long-term excavations, and Balbura, while the Konya Basin Archaeological Survey covers a substantial area on the plateau of south-central Anatolia. And here we have, again, a comparison using that aggregated data for those 3 zones, as it were: Sinop, Afgatangide in the north, Konya and the Göksu Archaeological Project, and then to the southwest, Balbura and Sagalassos. While absolute values for site numbers by period are partly determined by the size of the survey, the most important element is to observe trends over time for each case. The Konya Basin survey shows a maximum in settlement numbers during early Byzantine times, 5th to 6th centuries, followed by a dramatic decline during the 7th century. And the recent identification of forms of 7th and 8th century pottery suggests some degree of continuity, even though the lack of defensible sites and the need to maintain irrigation structures makes it likely that many rural populations abandoned their fields and villages entirely for the greatest security of the Taurus uplands. The Balbura survey suggests that, in contrast, settlement numbers appear to have remained high into the 7th to 8th centuries, after they'd already declined sharply at Sagalassos and in Konya and in the Göksu Valley. Yet at Sagalassos, for example, previously thought to have been abandoned by the middle of the 7th century following an earthquake and its consequences, there is now clear evidence for continuity, the construction of fortifications, and the existence of an effective community well into the 8th century, although much smaller. The mountainous Lycian hinterlands of Balbura were economically marginal but defensible, and the previous late Roman way of life seems to have continued here for longer. But interestingly, the Balbura survey indicates a substantial degree of abandonment at a later time during the 9th and 10th centuries, a phenomenon that cannot necessarily be ascribed to insecurity or warfare. Although this period is still poorly understood archaeologically, recent projects are beginning to identify ceramic material from the 7th to the 9th centuries, both at Sagalassos, at Balbura, and Sevaste in Cilicia. So to summarize the archaeological picture from which we've drawn the data, while recent work continues to indicate a clear decline in the number of inhabited settlements and a contraction of the physical space occupied by formerly urban centers, it also suggests that earlier impressions of an empty countryside in the so-called Dark Ages are misleading. In all the surveys in question, small amounts of material from the 7th and 8th centuries were identified where none had previously been detected. And with an increasing ability, due to intensive work by specialists on ceramics, with an increasing ability to detect and date ceramic material from the 7th and 8th centuries, an alternative model of slower reduction in settlement sizes in some regions, rather than a dramatic crash in all cases, has to be borne in mind. Most importantly, the data also indicates considerable regional variation, both in pace and intensity of change, and only careful further investigation of each case on its own terms will reveal the reasons for these variations. By the same token, suburban occupation continues around many cities that have contracted into a defended space, especially in areas not covered by our synthesis in Western and Central Anatolia. So, for example, at Ephesus, as well as at many other sites. Nevertheless, the century from the later 7th century onward did see a major reduction in the intensity of the human footprint in Anatolia, and archaeological surveys from all our regions, except that in a northwestern zone near to Constantinople, show a fall in the number of settlements of some 70 and possibly as high as 80% by around about 800 CE, compared with round about 600 CE. Now, I want to look at the some of the paleoenvironmental evidence and then put that side by side with the archaeological data to see what that might change in that picture, or whether it will confirm it. Changes in the archaeological record, so therefore, can be compared with the paleoenvironmental evidence, and then we can see where they seem to reinforce one another, where they diverge, where we need to shift our interpretation, certainly of the archaeology. I've just thrown up a map showing all the major sites across Anatolia from which we have pollen data. I should say, without going into too much detail, the chronology for a lot of this data, however, is not exact. There's often a variation of between 10 and 50 years, depending on the site and the dating, and also when the work was done. So quite a lot of the work, especially down in the south and southwest, at Gölcük, at Pınarbaşı, at Gölhisar, was done in the 1980s and 90s, and some of that now is being redated or reconsidered. And we have some new work which is being done by our colleague Chetin Shankal from the Meander Valley, which I hope, or we all hope, will help us be much more precise about some of the changes we're talking about. So the map shows all the potentially relevant sites from which pollen data is available. And we focused on those pollen records with some decent dating control during the period of interest. So in this case, from about 300 to 1300 CE, which means we've been very selective about site inclusion, as indicated by the table here. These are our main pollen deriving sites. The filtering process we applied produced 11 sites. And although in the case of South Central Anatolia, the pollen synthesis is based on a single record at Lake Nar, this site is actually remarkably well dated by annual sediments, and therefore gives us a really accurate record of land cover across the period when the pollen, for which the pollen was collected. And we then broke the pollen down into 3 basic categories representing different sorts of land cover. Tree crops, such as from olive, walnut, vine, ash, chestnut, and so forth. Cereal types, including wheat, barley, and then grazing indicators, various grasses on which livestock would graze. And we combined the data from the different sites to establish mean values for each sub-region for each century. And what was interesting were a number of things were interesting. Firstly, the regional differences. So as I'll show in a moment, whereas cereal pollen values fell to only 37% of their late Roman level in northern Anatolia, they fell to 13% in the southern region, 9% in the southwest, and 17% in the northwest, indicating very different impacts and outcomes for regional society and economy. And you can see the results of the regional pollen synthesis in this diagram here. For cereal type pollens, all subregions show a similar trend, with higher values during the first few centuries CE, followed by a fairly marked decline in the middle of the first millennium, and a return to higher values by the end of the millennium. The phase of low cereal values lasts between 2 and 3 centuries and is centered on the 7th to 8th centuries in northern Anatolia and the 8th to 9th centuries in southern Anatolia. These slight differences in timing lie within the dating uncertainty of the records used, so they shouldn't be overinterpreted. The common trajectory between the 4 subregions indicates that cereal-based agriculture declined across the whole of western and central Anatolia from the 7th to the 9th centuries, before recovering, often but not always, to former late Roman levels. Tree crop pollen shows a similar pattern to cereals between 300 and 800, namely one of high initial values in all subregions and subsequent decline. After about 800, however, there was a recovery in tree crops only in one of the subregions, namely northwest Anatolia, Bithynia, the broader region of Opsikion in Byzantine terms. In the 3 other subregions, tree crop pollen remained low throughout the remainder of the study period up to 1300 that we applied. Of course, there are significant intra-regional variations according to location, so we should bear in mind that regional values don't tell the whole story. We've created averages here which don't represent specific localities, but only the broader region. So the individual records can both distort the average and they can hide some of the details of neighboring from one site to another, neighboring sites. The general picture, nevertheless, is that cultivation of tree crops is widespread across Anatolia up till about 600 CE, but after that time it retreated to coastal lowlands of the west and northwest. We're unable to say whether a similar pattern applied to the coastal regions of southern Anatolia, such as Pamphylia and Cilicia, because we don't have the data. Finally, the pollen of grazing indicators, various grasses, shows a trend that is broadly similar to that of cereals, although values generally don't fall so low, some 60% lower than the level in late Roman times. Recovery, again, was regionally variable, but overall the pollen of grazing indicators returned to about 70% of its previous value after the 9th century. And note that these grazing crops only provide an indirect proxy for the pastoral economy. They can't be equated to past livestock numbers. Since individual pollen taxa vary in their production and dispersal, as I mentioned at the beginning, it's difficult to compare between the 3 land cover types directly, such as cereals as against tree crops. The pollen sites that we have are not fully representative of Anatolia's agrarian landscapes, and there is a need also for more and better records from agriculturally productive lowland regions before we can generalize with confidence. However, because these data are broadly consistent within classes or types of land cover, it is possible to establish long-term trends in agrarian economic activity. Where more precise data is available, of course, we can say much more about specific local conditions. This is exemplified in the material from Nargolu, Lake Nar in Cappadocia. The details I put up on the slide there. We're fortunate to have one of the few sites in Anatolia, so far at least, where closely datable pollen sediments can reveal the annual pattern of pollen deposition, reflecting thus more or less precisely what was happening to the landscape catchment area. And the pollen here, the plus minus variation on the dates here is 1 to 3 years. So that's remarkably precise. The lake, for those who don't know it, is located about 20 kilometers southeast of Nazianzus, 30 kilometers west of Malakopia, modern Derinkuyu. And I think that's on the slide there. Colonia, modern Aksaray, lies a further 35 kilometers west of Nazianzus. Analysis of the pollen sequence has provided a very high resolution record of vegetation patterns in the surrounding district for about 1700 years, i.e. from about 300 CE. The period from 300 to about 670 CE is represented by pollens from a mixed agrarian landscape with some areas of deciduous oak, woodland and grass-dominated steppe. The pollens from Nar show quite clearly that agrarian activity was reduced to a level that is invisible in the paleoenvironmental record during the later 7th century, in other words, after 670. And on the graph there, you can see that if you look at that, the blue shaded area on the main graph, you can see we've marked a number of key features. There's drought is perhaps an exaggeration. It's a rather arid late Roman period, but certainly not problematic for local farming. There is an early Byzantine wet phase, which carries on up into the middle of the 8th century. And then you have the medieval climate anomaly, and then the Little Ice Age setting in around about 1400, 1390 or so. But what's important about this is that the evidence for anthropogenic activity, human farming activity in this landscape around Nar and for a considerable distance in its catchment zone shrinks to virtually invisible, suggesting some very substantial changes. Now we can, some of you may know the articles that we've written on this. We can tie this in very precisely using Byzantine, Arabic and Syriac sources to a series of raids that took place in the late 660s and early 670s. And this may, I think, plausibly be correlated with and possibly causally connected with the shifts that we see in landscape and vegetation cover. Pollen distribution analyses, that, in other words, the technical analysis of the types of pollen that were collected from the sediments in the lake, and the ways in which they were distributed, either windborne, depending on weight, and various other features. Pollen distribution analysis suggests that most of the pollen deposited in the lake will have been regional rather than local. Thus, the record reflects landscape and vegetation changes across quite a large region of Cappadocia, giving us a pattern across the whole district in which the evidence for extensive human agricultural activities seems to cease or be reduced to a statistical minimum in the period between 664 and 678, to resume again, although with different emphases, in the middle of the 10th century. there is a major increase in tree pollen and a dramatic increase in crops such as olives and cereals. And this implies a period of marked decline in agricultural activity and an expansion of woodland and scrub vegetation. Even pollen percentages for grasses associated with steppe vegetation decline, probably indicating that some areas previously dedicated to livestock before the 660s, 670s were also recolonized by woody vegetation. Now, I should stress that an absence of pollen for anthropogenic crops such as cereals doesn't mean an absence of people, of course, but it does indicate a reduction of agrarian activity significant enough to leave no trace in the pollen record. And archaeologically, we know that the areas affected did continue to be occupied. There are a number of very small settlements, plus fortifications, of course, in the region. And they would have been producing some crops to live from, but they're not visible in our pollen data. So unless we can show that this food resource was replaced to compensate for the reduction, which we can't, then such a dramatic reduction in agricultural output must also signify, we argue, a parallel demographic reduction. The consequences for urban life in the cities of the region, such as Nazianzus and Colonia, in respect of food supply, for example, and labor resources, need further discussion, but there can be little doubt that they must have been very severe. A final point is that the NAR record also makes it abundantly clear that the significant changes that I've just referred to weren't caused by significant climate changes. So we have to think about human action rather than environmental factors as the main causal elements here. To return to the broader picture, based on currently available pollen data, overall cereal production during the late 7th to 9th centuries CE in all our regions seems to have fallen dramatically. It's important to remember that these percentages are arrived at region by region, so they don't differentiate between localities within each region, except insofar as particular sites with different results can be compared to indicate chronologically parallel local variations, as at Lake Nar, for example. There are also significant variations in rates of change and degrees of change, although they do not show clearly on the table I produced. The shift in northern Anatolia seems to be a little less dramatic than elsewhere, for example. By the 11th century, cereal production appears to have recovered to above previous levels, but with significant regional variations. So in central and northern Anatolia, where cereal production reached values significantly above those achieved in the 5th to 6th centuries. This was not the case in the southwest, where overall cereal production recovered to only about half that of late antiquity. As you've seen, as I hope you've seen, at least from the graphs, the fall in tree crops was similar to that found in cereals, but only 2 of the 4 sub-regions show evidence for medieval recovery. Pollen evidence for economically significant medieval arboriculture is restricted to the lowlands of northwest Anatolia, the region closest to the capital of the empire, as I already noted. A similar pattern is evident in pollen records from western Anatolia, not included in the 4 regions that we've used for our pollen synthesis. For example, at Gölcük near Sardis, where sweet chestnut appears to be a major commercial crop from the 9th century and possibly earlier, and at Bafa near Miletus, where olive and walnut cultivation continued from classical right through to medieval times. So we need to bear in mind again, and I can't stress too frequently, the high level of importance of regional variation. The data also indicate a change in the relative proportion of crops to one another across all 4 regions, by which pollens associated with cereal production and livestock raising come to dominate at the expense of those associated with the cultivation of vines and olives. And there is a considerable reduction in the presence of pollens from fruit trees of all types. But within the regional statistics, this particular shift only affected some areas, while others, often adjacent, continued the traditional pattern. In all cases, as we've said, the scale of production was very considerably reduced. So what we have here is within some of these regions where across all the indicators, there's a reduction in outputs. There are also changes in emphasis between neighboring communities or neighboring landscapes. So in some, the traditional pattern of agriculture continues on a reduced scale, but in others not too far away, a different pattern emerges, as I said, with an emphasis on cereals and livestock. And we have to consider what might, given that there's no climatic impact to consider here, we have to think carefully about what might have been the reasons for those changes. Two other conclusions can be derived from all of this data. First, the pollen indicates that cereal cultivation recovered more strongly than either tree crops or grazing activity, suggesting perhaps a more elastic response following a period of disruption. Secondly, it also indicates the return of less labor-intensive pastoral economies first, followed by more labor-intensive cereal cultivation second. The recolonization of landscapes that had previously been abandoned and turned wild may thus have been a two-stage process. And this perhaps reflects a shift from less to more secure political conditions and can be associated chronologically with the later 10th century Byzantine economic as well as political recovery. Before concluding, just a couple of quick words on another element, namely climate. Again, as many of you will be aware, Anatolia is the focus for three global climate systems which interact: the North Atlantic system, the South Asian summer monsoonal system, and the continental system located across Northern Asia, Western Russia, and Siberia. And together with the very varied geography of Anatolia, this creates a highly inflected climate regime with very significant interregional and sub-regional variations. And these also need to be built in to our broader picture. Paleoclimate data is drawn from a wide range of proxies, including speleothems, that's to say stalagmites and stalactites from caves, lake sediments, tree rings, as well as oxygen isotopes. And the data show generally dry climatic conditions in Anatolia prior to the 6th century, followed by a rapid shift to a much wetter climate in the later 6th and 7th and early 8th centuries, lasting until the 750s. And this sequence of changes is supported by documentary records of drought, flood, and famine up to a point. And you recall I showed you the chart when I was talking about the work of Telelis on textual data at the beginning of the talk. And although the material, the documentary data from our sources is suspect for all sorts of reasons, it does, interestingly, tend to coincide with the paleo-environmental evidence. So the accompanying instability across time in temperatures would have been especially significant for tree crops in upland areas of Anatolia, many of which lie at or above the limit for cultivation of olives and vines, both of which, again, as you all know, are sensitive to winter cold and spring frosts. So the paleoclimate evidence complicates things further, and again, forces us to pay attention to microclimatic regional differences and regional variations, both in farming, in land use, in productivity, and in markets. So what does all this mean for the history of urban settlement and the history of towns in the Byzantine world between the middle of the 7th and the 9th centuries, or the 10th century? The first point, to go back to the point I've just made, a climate reductionist model doesn't work. There's no coincidence between climate shifts and social and economic change anywhere at all. Indeed, all the evidence indicates that human activity, long-term social economic changes, warfare, disease, and political insecurity were the root causes. Finding specifics within that set of potential causes is, of course, a different matter. Secondly, the archaeological indication of an apparent fall in the number of settlements between the 6th and 9th centuries of 70 to 80% by about 800 CE is paralleled by the pollen data for the scale of decline in cereal and tree crop production. Obviously, we need to take account of the problem associated with the nature, number, scope, and size of surface surveys, and it's by no means clear that a number of potential sites have still to be identified. Absence of evidence is not evidence of absence. Still, the overall picture from such very different regions is at the least indicative and should encourage ongoing, extensive further survey work. And finally, it's important to remember the regional differences By way of comparison, pollen data from our region 1, Northwest Anatolia, suggests that this area was less seriously affected than the other 3 sub-regions during the time period I've been concerned with, although the archaeological data from surveys in Bithynia are less complete than from some other regions. Again, I've mentioned this twice already, this area was, of course, nearest to Constantinople and farthest, mostly, from the Arab-Byzantine frontier zone, and appears to have retained a more traditional late Roman type of rural economy until medieval times. Nevertheless, evidence from sites such as Iznik also show that there was a real decline in the agrarian indicators between round about 650 and 800, even if this phase was of shorter duration and ended sooner than elsewhere. So the congruence in pollen data for cereals, tree crops and weeds or grasses across a number of spatially distinct sites in northern, northwestern, southwestern and central Anatolia cannot be accidental. Furthermore, it both mirrors and gives credence to the picture that is emerging from the archaeological survey data. It shows clear evidence of land abandonment and a major decline in rural population, although decline was more gradual and less severe in some areas than elsewhere. The impact on urbanism in consequence must have been substantial. For example, demographic decline of this order of magnitude would tend to reinforce the lower estimates for the population of Constantinople across the later 7th and 8th centuries. It would explain why early medieval armies, especially on the East Roman side, were so small compared with those of earlier and later periods. Such changes might also help to explain why many older but previously unimportant urban settlements became more important. To be sure, many such sites also had a strategic or other cultural significance. But we might also wonder whether shifting environmental conditions also contributed to their changed situation. Efkaita lay in an area which we know benefited from greater rainfall from the later 6th or earlier 7th century, a situation that would have been good for cereal production. Amoria, a relatively unimportant town until the 7th century, although considerably larger than Efkaita, lay in a plain surrounded by medium quality arable suitable for cereals, and again would have benefited from slightly greater humidity in the 7th to 8th centuries. The point is, the paleoenvironmental data offer an entirely independent source of evidence that can be used to corroborate, to challenge, or enhance and nuance interpretations based on written and archaeological data. And this opens up a new way of looking at the history of early medieval cities in Byzantium. This data may not solve, and it certainly does not solve our problems and answer all our questions, but it does perhaps help us to ask the right questions of our evidence and to guide the path of ongoing research, both on the broad scale as well as for individual regions and specific sites. And the main point is the paleoenvironmental data offer an entirely independent source, evidence that can be used to corroborate, challenge, enhance, or alter our interpretations based hitherto on the written evidence from the archaeology. And this opens up a new phase in the history of early medieval cities in Byzantium. Thank you very much for your attention, and I hope I didn't talk for too long.
No, you didn't talk for too long at all. And thank you very much for this wonderfully detailed presentation, Professor Haldon. It was really illuminating to see, as a prehistorian myself, the strengths of archaeological methodology employed in the Byzantine period archaeological evidence beyond text, and putting everything in a long-term perspective and anthropological frame. So I am now opening the floor for questions. If you have any questions for Professor Haldon, please go ahead and raise your hands or turn your videos on so that I can see.
Luca.
Yes.
Hi, John.
Hi.
Sorry, wonderful talk. I caught 3/4 of it because I've just rushed back home from teaching. A quick question, because I'm curious about what you think. I was supposed to ask you in Birmingham and I completely forgot. Pairing this evidence from Anatolia with the one coming up slowly but surely from Sicily, for instance? How do you see the picture there in a comparative perspective? I mean, maybe there is something also coming up from Crete. I'm not sure, but hasn't been fully published. What do you think? Do you expect this thing to change a bit or to stay the same?
Excuse me, I just let the dog out of the room. He's trying to get out.
I have the same problem. But
My apologies.
I have the same problem, but mine is sleeping. I mean, most probably it's used to me.
So I think, firstly, the new evidence coming out of Sicily in particular, but also from Crete, again, we need to go back to these regional and micro-regional variations. So I think it'll change some things and it'll reinforce other things. I just published in a festschrift recently for Hugh Kennedy, a short article about some palynological evidence from Crete for olive cultivation near Lake Kournas on the northwest coast of Crete, showing that round about 650, which coincides quite well with the first major Arab raid on Crete, there is a sudden collapse of olive production in this one particular little catchment area. Now, we can't generalize because we have no data from anywhere else at the moment. But that might be an indicator that anthropogenic activity can have fairly dramatic implications. What's interesting about that site, I'll come on to Sicily in a minute, is that whereas olive cultivation is affected very dramatically, cereal cultivation isn't affected in the same way. So clearly the crop that was most easily destroyed and damaged and harder to replace, namely olives, didn't recover, whereas cereal cultivation, if it was affected at all, carried on. So again, that's a good illustration, if the interpretation is correct, of course, and if the pollen data is reliable, that's a good indication of how different areas respond resiliently, if you like, or flexibly to very similar stresses. In Sicily, we did some work which we published. I'm just trying to remember where we published it. I think it was in Quaternary Sciences Review about 5 years ago. Adam Izdebski led the group, and they've got some very interesting material from Sicily showing a continuity of production and increasing levels of apparently increasing levels of production for cereal crops well into the 8th century. But towards the end of the 8th century, a decline, a fairly dramatic decline. Now, in this case, it does coincide with declining precipitation levels, apparently, and increased aridification. So there could be a rather complicated relationship then between the successes of the North African Saracens in Sicily in the 820s, climate, production levels and farming strategies, and also tax round about that time, which we haven't really worked out yet. So there are the evidence from Sicily raises interesting questions, but the important point is that Sicily, of course, is in a very different geoclimatic zone at the micro level. I mean, it's part of the bigger Mediterranean zone, but that Mediterranean zone breaks down into many sub-regional zones or subzones, and Sicily is in a very different place from Western Anatolia, or certainly from Central Anatolia, for obvious reasons. So the point is, I think that we're really only beginning to realize now how important this evidence can be, and part of the problem is getting the funding and the resources and the teams of specialists together who can now pursue the broad strategic sort of survey work at all levels that we need to do. And I don't, if I was a multi-millionaire, I would be happy to give all my money towards expanding regional surveys in Anatolia and the Balkans. But
I will take some of that. I will take some of that money for sure.
I hope that answers the question.
Thank you, John. Of course. Thank you so much.
I think we have 2 more questions. Joanne?
Yes, I was wondering, there's a similar period much later in history in Anatolia, similar sort of situation to what you're talking about, that is has good coverage for rural areas. That's one advantage for it. I was wondering if you'd taken a look, if anyone's done any work on that. It's the Jalali rebellions, much later in the Ottoman period. It's much, it's very similar to what you're looking at. If someone has done some studies there, you know, with the records and so forth, it might be of interest. I mean, I'm not obviously asking you to do that, but I thought it might be interesting to just check out and see if anybody has done any work on that that's similar to what you're doing, and then you could kind of run the different periods off against each other. I thought that might be kind of interesting.
Yeah, thanks. It's a good question and a good point. Some work has been done. I mean, Sam White, as you probably know, wrote a book called The Climate of Rebellion, all about the Jalal rebellions.
Okay, all right.
And he tied that into what evidence we had when he wrote the book, which is about 15 years ago now, to the climatic data. But more recently, we are actually involved with the project. I mentioned my colleague Chetin Shenkul. We have a lot of pollen data, or we're collecting a lot of pollen data from the upper Meander Valley. And we also have, for the Ottoman period, we also have Tapu Tahrir Defterleri, which are, as you know, detailed tax records for the different communities. And we can compare the evidence from those. There are quite a few of them for the 18th, 17th centuries for this region. We can compare these with the profiles from the landscape use data that we've got. The work is only sort of in its infancy. We published, or at least the group, I wasn't part of this particular publishing group, but Warren Eastwood, Chetin, and a couple of other colleagues, Neil Roberts, have published some data already on this. And we're now in the process of working with some Ottomanist colleagues who have access to the Başbakanlık Archivi in Istanbul, and they're trying to extract the relevant defters for our region and period. We also were able to do that to some extent for AFCAT, because the TT31, I think it is for the 1540s, and that's for the village of Afkat, or Avukat it's called, in the Ottoman material. So we can take the story for Efkaita. I stopped because of my Byzantinological focus in the 11th, 12th centuries, when it's occupied by the Danishmendids anyway, but for a while. But you can actually follow the history of Afkat right through to the Tanzimat. So we can do a continuous history for some of these regions. And as Chidem certainly knows, the pollen data can often go back several millennia. And be used in combination where there is any epigraphic data or architectural data to do the same sort of thing. I mean, the Byzantine period and the Roman period are useful because we have a lot of written testimony, and the Ottoman period even better. But very few Ottomanists have yet got into working with paleo-environmental scientists. A few have, and there's a book came out which I co-edited with Chris Roosevelt at ANAMED in Istanbul, called Winds of Change, which is a conference we had in Istanbul 2 years ago. And a number of Ottomanist colleagues, as well as prehistorians, contributed to that, looking at the way in which environmental data can be used to complement historical and or archaeological evidence. So the work is progressing, but we're still in our infancy, in a sense, in that respect.
Yes, Perry Johnson.
Okay, so hello, I'm on my phone. So my question, I'm starting a new project, so I'm really thinking about alpine pollen records right now. But my question really has to do with the status of the alluvial plain in late antiquity, and particularly how I was just, you were speaking about the Lake Nar records, how because of the deep alluvial deposition that we're sort of lacking that period of sites in many alluvial plains. And so, yeah, so I was really thinking about, you know, this recovery in the mid-10th century that you were speaking about for Lake Nar, and how that might, I know that you spoke so eloquently about regionalism, but at the same time, I was wondering if you think that if you thought much about the alluvial plain and like the inland drainage basins, but also just anywhere such as along the Sakarya River Valley, or where I work in Northwest Konya, where there is like extensive alluvial deposition in this period.
So I haven't done any work on them directly myself, but the colleagues who are working at Ephesus, for example, obviously they have a harbour zone which was gradually filled up from late antiquity onwards, and they've done some work, some pollen work there, and got some very interesting results. Also for Lake Baffa, there is a colleague, I can't remember which university she's at, Sena On, who is working on the pollen and other paleoenvironmental data from Lake Baffa. So I think there is some good work being done. And I can't remember the details now, although Sena actually came, and also Sabine Ladstetter, who runs or used to run the Ephesus excavation, have both been to some of our meetings in Princeton and presented their data to us. So again, as with my sort of point response to the previous question, the work is being done, but it's piecemeal at the moment and slow, and there's not a huge number of people involved in it. But the other issue, actually, which comes out of your question, is that quite a lot of work is being done by Turkish scholars and scientists associated with engineering projects, hydrological projects on behalf of the Turkish government. And there's a lot of data that they've generated, which archaeologists and historians should ask them for, because quite a lot of the data is actually there. It's just that we don't have access to it because we haven't talked to the right people. And so I think there's some interesting joining up to be done. And certainly when I've talked to when I was in Istanbul last year, talking to a couple of people I happened to meet by accident who are engineers working for hydrological survey in central Turkey to do with water tables and other very pressing hydrological problems that Turkey is currently facing. They were fascinated to find that their work can be relevant to historians and archaeologists. And just as importantly, that what the archaeologists can tell them about the way people manage their environments pre-industrially can actually be relevant to thinking about contemporary planning issues. So there are lots of places where we could join up if we had the possibility of meeting and talking. And that's where I think conferences such as that, there's a project currently being run by the British Institute in Ankara, which is all about water management, both in Istanbul and elsewhere. And it involves local communities and stakeholders, government, local government administrators, central government representatives and so forth, trying to link in the historical, archaeological and paleo data to contemporary issues of environmental sustainability and management. And the coastal regions, the wetlands and so forth, are particularly important in this respect because of the impacts of tourism, amongst other things, as you know, general overexploitation issues. So the short answer is I haven't given it much thought myself because I don't work in those regions, but I'm aware of the work that is being done, or some of it, and again, we need a lot more of it. But it's all relevant, of course, because it emphasizes at one level a general tendency, but when you dig down into each sub-region or sub-locality, you can see the specific variations that combine to give you this general impression. So thanks.
Yes, thank you very much. I think I'm sure people have more questions, since this talk is going to be also online on our YouTube channel in a very short while, I think you will receive perhaps even more questions from the colleagues. So 3 questions should be enough for us this evening. I think you must be very tired, and we should be thanking you very much again for being with us and sharing all this incredibly rich data and interpretation. Thank you.
Thank you very much for inviting me. Thanks a lot.
Thank you.
Bye-bye.
Bye-bye.